Okay. Assalamualaikum and hi everyone. Okay, so this time is a session for me to teach or explain on the separable method for solving ordinary differential equations. Okay, so you already knew that there are 4 course outcomes for this subject. Okay, so the first outcomes are related to solving ordinary differential equations. Okay, so in short form we call as ODE. Okay, so they are first ordinary differential equation, first order and second order for this ODE. Okay, so I will start with the first order. Okay. Okay, so but let me introduce first the form for this ODE. Okay. Okay, so the materials for today's topic you can find in the e-learning. It comes from the first ebook, okay, of John Bird. Okay, the page number is 444 for first ODE. Okay, so when we call as ODE, it means ordinary differential equation, okay, or we can call it as differential equation. So usually it's called as ODE, so it's very simple. Okay, so the first part that you have to know is the order, okay, the form that these equations have. Okay, so let's see here the first equation, the first part, part 1. So dy dx is equal to 7x. Okay, so this is common notations, right? Okay, dy dx equal to 7x. There's another way to write down. Okay. Okay, there's another way to write down the equation. So we can write down here y prime is equal to 7x, right? Okay, so instead using dy dx, you can use y prime. Okay, so dy dx is a common notation, or y prime is common notation. Okay, but it's called common because we have variable in terms of x, so we write down as dy dx. But you have to adapt if the notations or symbols are changed. Okay, for example, we have dp over dq is also first ODE. Okay, but the dp over dq also can be written as what? P prime, right? Okay, so P prime. So you can check that when it's written like this one in the second part here, d squared y over dx squared plus 5 dy dx plus y. Okay, so the second one here is the second ODE. Okay, we call second ordinary differential equation. Okay, so let's see between these two equations. So dy dx equal to 7x, we call it as first ODE. Why? Because the degree as dy dx is 1, that is the highest degree, right? So among of it. So we call that this equation in the first part as first ODE. Okay, for second one, why we call this as second ODE? We have also y, we have dy dx, we have d squared y. So with, between this in the equation, d squared y is the highest order, right? So we call it as second ODE. Okay, so in the equation, in the first equation, dy dx, okay, there is power 1, okay. dy dx, you can assume it's dy dx in brackets to the power of 1. So for this one, part 1, we call that the degree of the equation is 1, okay. So dy dx equal to 7, x is also known as first ODE, and it has a degree of 1. Okay, for the second part here, this equation is order 2, okay, has an order 2 and a degree 1, okay, because you can check here, d squared y, dy dx, everything here in the bracket is to the power of 1. Okay, so let's see here. There's some parts different here, okay, this one. Okay, this equation, as shown here, the one that I highlighted, this one, you can see, right? Okay, so this equation is second order, second order of ODE, and it has degree of 5, okay, because they see that this is degree 3, this is degree 5, so the highest is 5, okay. That's why this is also a second ODE, but it has degree of 3, okay. Okay, so I'm going to continue to the first method for solving first ODE. So first part we will cover for the solution for first ODE, and then we move to the next one, solving second ODE. Okay, so one of the methods for solving first ODE we call separable variable. Okay, separable variable. Okay, there are many forms we can do for separable variable. Okay, so we see here. Okay, it's called separable variable because the method that we do in the equation is separating according to the variable. So this first method usually is called separable variable. Okay, in other words, we call it also as separating the variables. Okay, so let's see the first one. Okay, so the first example that I'm going to see here is okay, the first form. There are many forms for the separable, separating the variable. Okay, so this one, we call this one, we do separating the variable by this form. Means that y equal to integration for fx dx. Okay, so means that the original equations is not in the form that in the box here. So means that you have to transform it so that it becomes to the form that similar to the one in this box. Okay, so once it have, then we do integration. Okay. Okay, so let's see this example in problem number 2. The question is determine the general solution of x dy dx equal to 2 minus 4x power 3, right? Okay, so first one you have to rearrange. Okay, rearrange because you can see that the original equation in this problem is not the same with this one. So we have to transform it. Okay. So to transform it, it means that just make it first. Okay, dy dx. dy dx, because to make it that this one becomes here, you have to separate. Y goes to y, the left hand side will be the y, the right hand side will be x variable. Okay, so this is basic one. But you have to adapt if the variable is changed. If it's not y, x, then you have to modify it accordingly. Okay? Okay, so we know that dy dx, if it's on the left, we do integration For the left side, it becomes y. Okay, so if on the right hand side, it is x with the some constant, and you want to integrate, it becomes something in the x variable. Okay, so this is as the example. This is the original equation, right? Okay, so this x you have to bring to the right hand side. Okay, so this x you have to combine with here. Okay, now let's see the one x here. It is x times dy dx. So it is on the left hand side. But if we bring this x to the right hand side, so the times will becomes divides. So x bring it to the right hand side. So the equation this on the right hand side must be divided by x. So it becomes here. Okay. So x, there is no more x here. So it moves to the right hand side, becomes divides. Okay, so it is simple maths actually. So I hope you can understand. Okay, after that, this is one combined fraction. But because there is a part numerator and denominator, we know that we cannot do integration, right? If it's as combined. But we can do integration. You can do the integration if this one fraction be separated to two different fractions. Okay, so we have this one separated. Okay, so 2 over x means dy dx is equal to 2 over x minus 4x power 3 over x. Okay, so this one you can simplify, right? So we can do cancellation. So here will be x to the power of 2. So it can be simplified. Now, this is the one that we are going to integrate the next step. So the next step is actually we have dy dx here. The left hand side dy dx equal to the right hand side. Okay, this one. So dy dx integrate with respect to x, we have y. So integrate this one. Okay. Integrate this one, we have his answer. Then plus constants. Okay, so don't forget. Okay, so 2, we know that you may refer to the formula list here. Okay, integration. So refer to the formula list at the second column of the integration, right? Integrate this one, 1 over x. Integrate 1 over x here. We have ln x. Okay, so these two you can make it outside. So we have 1 over x. So and then 2 times ln x. Okay, so this one is direct integration, right? So using rules of power. See, rules of power is here. Okay, the number 2. This is rules of power. This is rules of power. Okay, and then 4x power 2, so it becomes 4 over 3x power 3 plus c. Okay, so this one, the one I highlighted, we call it general solution. Okay, there are two different types of solution for solving ordinary differential equation. Either is for both for first ODE or second ODE. So general solution, usually your answer will be the equation and then plus c as a constant. So it's called as general solution. But if there's a question to find out what is the value of c, then it's called as particular solution. Okay, so to find out the particular solution, usually in the problem, there must be an initial value given. Okay, initial value given. Okay, but if you see in the problem number 2, there's no initial value. It's just only one equation. Okay, no initial value. So, so here is just, the problem is just to find the general solution for first ODE. Okay, so we'll see the next example. Okay, so the next example, let's see in this ebook. Okay, the problem number 3, question is find the particular solutions of the differential equation. Is here, given the boundary conditions here. Okay, so this time question is to find particular solution. And we will see that there's some initial values given. Okay, so first one, let's see, this one is not the form in terms of dy dx. Left hand side, to x variable that is equal to right hand side. Okay, so you have to modify the equation. Okay, so this equation you have to modify it. First thing, this 5, bring it to the right hand side. Okay, and then plus 2x need to bring to the right hand side. Okay, now let's see. Between 5 and 2x, we do 2x. Okay, we do 2x first. So here plus 2x, right? So 5 plus 2x, bring it to the right hand side, becomes minus 2x, right? So we have 3 minus 2x. Okay, so 3 minus 2x. So this plus 2x bring to the right hand side first. Okay, and then this 5. Second part, this 5, bring it to the right hand side. This is times, so bring to the right hand side, then we have divide. Okay, so we have this form. Right? Okay, so this is a combined fraction, so we separated it to 3 over 5 minus 2x over 5. Okay, or this one also we call 2 over 5x, right? Okay, so 3 over 5 is a constant. So the left hand side we have dy dx equal to this one. Okay, so the right hand side is the form that it's easily for us to integrate. Okay, and then we refer to the formula list in the integration. Okay, so dy dx we integrate, we have here. Correct? Okay, so integrate this one with respect to x variable as shown here. Integrate 3 over 5 is a constant, correct? Okay, so 3 over 5 and then integrate, we have 3 over 5x. Okay, here 2 over 5x integrate, so this is x power 1 and then plus another 1, so we have x power 2 over 5. Okay, so the one that highlighted here is the general solution, but previously the question asked us to find the particular solution, remember? Okay, so to find the particular solution after we have the general solution is just substitute the initial value given. Okay, so the value given this one, when y is here, x is 2. So substitute into our general solution. So substitute here, 1 and 2 over 5. This is mixed fraction. So convert it to proper fraction, improper fractions, or you can use calculator directly. Okay, and then 3, this one times substitute times 2, right? 3 times 2, and here 2 power 2. Okay, and then we have everything, all numbers except c. So means that we can solve the equation, right? Okay, so solve it. So we have this equation. Then we solve c equal to 1. Okay, so after that, don't forget to substitute back here. Okay, c as 1. So the particular solution is written as y equal to 3 over 5x minus x power 2 over 5 plus 1. Okay, so that's is the answer for the second example. Okay, so next one we'll see another form for conducting a separable variable. Okay. Okay, so in the previous one, we do separating the variable by doing y variable left hand side, x variable on the right hand side, right? So we start with dy dx, dy df of the left hand side, then the remaining part will be goes to the right hand side. Okay, so in the second one, we make it to this form. Okay, make it to this form, and then we can do direct integration. Okay, so means that the second part, the left hand side is integration for dx equal to this one, integration for dy over fy. Okay, so usually this second one, it must be contain a fraction where we move it. Okay, so the next example, find the general solution of dy dx equal to 3 plus 2y. Okay, so we see that this one, Okay, is not equal to this one, right? So we have to transform it so that is equal to the form on the in the box. Okay, so how to start? Okay, so we see that here 3 plus 2y, everything, if it is actually is the whole thing, we can combine it because there's a y, so it must follow dy. So dx, bring it to the other side. Okay, so rearrange. So rearrange, we have like this. Okay, rearrange. So there's no problem whether the dx is on the left hand side or the dx is on the right hand side. Okay, because you can switch. Okay, so you can switch. Okay, so you can switch. So the original equation is being given here, right? Okay, so next from this one, we do integration. So integrate here, integrate here. So the left hand side integrate with x variable, integrate the right hand side with respect to y variable. Okay, so integrate this one, we have x. Okay, so the issue is here how to do integration on the right hand side. Okay, so the left hand side we have x. Okay, so the right hand side is to integrate 1 over 3 plus 2y. Okay, 1 over 3 plus 2y. Okay, so 1 over, so there's integration 1 over 1 over 3 plus 2y. Okay, have dy, right? It's the same form, right? So we can write down here, correct? Okay, so there's no direct integration, so means that we have to do a special method. Okay, so several methods we can use substitution for this integration. We can use partial fraction. We can use integration by parts. Okay, so there's another form, another method that we can use is the trigonometry identities. However, this function is not trigo, right? So you can use that one. Okay, so we'll start or let's try with the substitution method. Okay, so the substitution method, we let this one becomes as u. Okay, so that one is becomes of u. So we have u equal to 3 plus 2y. Okay, so differentiate here with respect to u. So we have du equal to dy, right? Okay, so everything here, we can change the y and dy to the u. So it's equal to integration of 1 over u. So dy, dy here, so these two you have to bring the other side, so it becomes half du, right? Du. So it's equal to dy. So this one equals equal to half du. So then equal to half integrate. Then next one is integrate. So we have half ln u. Right. So half ln u, change back. What is your u? U is 3 plus 2y. Okay. So so this is the answer for the integration on the right hand side. Okay, so let's see back. So the right hand side we have here half ln 3 plus 2y. So we have x equal to ln 3 plus 2y, then plus c. This is the last part. Okay, so if there is a question for you to find out what is a particular solution, then use the initial value. But in this question just now, there's no initial value given or boundary value given, so means that just to find out the general solution. Okay, so I think I will stop for now. But for today's topic, I would like all of you to do practice questions in the ebook. Okay. So these are the given practice question for you to try to solve. Okay. So I have covered two forms for the separable variable. Okay. If we want to do separating the variable in order to solve the first ODE, then we need to identify the form first, right? Okay, so they are for today I have explained for two forms. Okay, but you just need to differentiate whether the solutions required are the general solution or particular solution. Okay, so the practice question for you to try in the ebook. Okay, so you may refer exercise 178. So for today's topic, it starts from ebook John Bird, page number 444 onwards. Okay. So please do practice question exercise 178, question 1 until 8, and then exercise 179, questions 1 until 7. So all questions are covered for these two forms of separating variable. Okay. So that's all for today. Thank you.